I want everybody to welcome to the stage with a warm round of applause, Sam Newman, who is a technologist, which is great because the gist of this conference is technology. Sorry, Dad. Okay, everybody, welcome Sam to the stage.
Hello, everybody. So there are seats at the front. I am not going to do any crowd work, so you should feel free to, I'm an old man now. My back hurts looking at the people standing back there. Come up towards the front, and there are seats available to you. I do, actually, you should go and visit all the sponsor booths as well, because without them, the conference does not exist. And we do need, next year, more people with like proper barista stations. So more times you visit the sponsor booth, the better the chances of the queues for good coffee being shorter next year. And maybe we'll work out how to show you the trailers of the latest Mission Impossible film as a thank you to all of that. So I'm here to talk not about the things that I normally talk about necessarily, because I'm somewhat known for talking about microservices. And don't worry, that bandwagon is alive and well, and I am surfing it as long as I possibly can. But I wanted to take a diversion to really explore something on the periphery of this space. I mean, look, I spend a lot of my time thinking about, not moving in front of that speaker, I spend a lot of my time thinking about boxes, right? Boxes and the arrows between those boxes. This is, you know, architecture sounds complicated, and this is mostly what it's about. Now, boxes and arrows, a lot of my time is spent talking not just about boxes and arrows, but how big some of those boxes should be, and maybe how small some of those boxes should be. Occasionally, we have more edifying conversations where, rather than talking about how many boxes you've got, we talk about how to take existing boxes and to break those down into smaller pieces without actually making them new boxes. Revolutionary stuff. I actually often like to talk about the shape the boxes should be, and I have firmly, of course, put my weight behind Team Hexagon. And this is not just because Alistair Coburn is doing a talk here, but you should go and watch his talk, because obviously he is the person that gave us hexagonal architecture, and it's his fault that I use hexagons. But actually, all of this stuff aside, when you start talking about architecture, often the most interesting thing is not the boxes, it's the arrows. The arrows between these boxes, because this is where architecture, certainly systems architecture, starts to come alive. And I talk a lot about microservices types of architectures, and so a lot of the times, because we have more boxes, we also therefore have more arrows, and I end up having lots of conversations with people about what these arrows are. Now, this is going to be a talk mostly not about microservices. This is going to be a talk mostly about meaning. And I may even mention the word semiotics, but only briefly because I didn't actually learn what it meant. I just heard it from a smarter person than I did. But before we get into that, if we're going to talk about meaning, I need to be clear about some meanings. And one meaning I want to be clear about is what I mean when I draw an arrow. It seems like a simple thing. What does an arrow mean? When I draw an arrow in a diagram like this, I am showing a form of logical dependency. I'm not talking around data flow or anything like that because, you know, data always flows in two directions. I'm talking about a logical dependency, a dependency between two things. So in this little simple example here of a microservice architecture, we can see a dependency from the returns microservice to the shipping microservice. What this means is the returns microservice depends on functionality that is provided by the shipping microservice. And that is it, really. At a logical level, when we're thinking about our design, that's the level at which we care about these things. But of course, we have to go beyond thinking in terms of logical architecture, because occasionally, we might actually have to build something. So then we have to go from the logical world to the implementation world. You know, that sort of mucky stuff that all of you lot get involved with, which is called programming, which I try and distance myself from as much as possible nowadays. And then the conversation when we get into implementing these arrows comes down to people saying to me, Sam, tell me, synchronous or asynchronous? And I'm here to tell you, that is the wrong question. Because actually, this is kind of meaningless. And I sort of didn't realize how meaningless this distinction was until I started writing my most recent book and realized I couldn't get good definitions for these terms. And this is also why I've tended to prefer to talk about distinctions in interactions, not in terms of synchronous and asynchronous, but instead in terms of different types of logical relationships, because I think the distinction here is more clear. So I've much preferred talking about the distinction between request-response and event-driven. If we're thinking about logical interactions, the distinction here is quite significant, more significant in some ways than synchronous and asynchronous. I'm going to explain what these terms are very briefly because, again, this is a talk about meaning, and I want to be crystal clear about what I mean by these terms. You might have different meanings for these terms. I don't care because it's my talk and I win. So let's talk about request response. This is the most common style of interaction that you will typically see. It is the one that people will often default to when first building, say, a service-based architecture. A microservice, in this case the returns microservice, needs to accomplish something. And it needs to do that, it needs to collaborate with another microservice. And so what it does is it will send a request. So in this case, I am asking for a postage label. I'm saying, hello, I need a postage label. Can you please provide me a postage label? This is the request. The return service here is initiating the operation. And hopefully, we get our postage label, or we get an error, or maybe nothing at all, or maybe some random bits and bytes. These are the exciting aspects of any distributed system. So in this environment, we talk about the returns microservice as being the consumer. It consumes other services functionality in this particular example. Very simple, very straightforward. We then come to the world of event-driven interaction. And this inverts things. So in this example here, a microservice is emitting an event. This event, think of it like a fact. This is something which has happened. The stock level has changed. And all we're doing at this point is communicating that fact. We don't really care if anyone listens to that piece of information. We might as well be putting it on a notice board and walking away. We are unaware if anybody actually consumes this event. That's the key thing about when you emit an event. By the time it's communicated, that's as far as you're concerned, that's it. It's then up to other microservices to decide that they care about that event. They are the consumers. But unlike with request-response-based interactions, they're not the initiator of the interaction. They are the recipient, but they are also the consumer. They are consuming the functionality. And they can choose to do different things with the same piece of information. So in this case here, the promotions microservice, which does discounting, might decide to discount a product automatically when the stock level reaches a certain amount. The wishlist microservice, on the other hand, might decide to do something quite different. It might say, well, actually, I know that Daniel is a big fan of Justin Bieber, and the latest Justin Bieber album has come out, and so I need to let him know because he and the other believers really want to listen to the latest cut from Biebs. So I'm going to send him an email or something. So I actually think this distinction is quite clear and quite crisp. And you can get variations on a theme, but when you're thinking about interactions around a whiteboard, these distinctions are quite important. But we see here an inversion. The consumers go from being on the left initiating to being on the right receiving. And yet still, people really want to say, but Sam, no, synchronous or asynchronous. And when I try and sort of bring these worlds together, I would talk about the way in which something like request-response-based communication can be either synchronous or asynchronous in nature. And so when you start thinking about how you're going to implement request-response-oriented communication, you've still got a wide variety of options available to you. Event-driven interactions, though, blimey, went too fast there. Event-driven interactions, though, are inherently asynchronous in nature. And then I sort of realized by going through all of this that actually that's kind of true, but also at the same time, I don't actually know anymore what the term asynchronous means. So I'm starting off this talk explaining to you and sharing with you the fact that fundamentally, I have become less smart, I think, over the last 10 years, because the more I look at this word, asynchronous, the less it means. And I was prompted to write this talk after reading this blog post by Pat Helland. So if you're interested in distributed systems or computing in general, and you're not subscribed to Pat Helland's Substack, you should be. It's very low volume, but very high signal. And in this particular article, Pat is looking at the term eventual consistency. And he's making the argument that we should not call it eventual consistency anymore because we use the term consistency in so many different contexts. And those different contexts give it totally different meaning. What consistency means in the scope of an ACID transaction has no relation whatsoever to the term consistency when we talk about eventual consistency. The only thing they share is the word, but they share none of the meaning. Don't believe me? Go and look up what the C in ACID actually means, and you will be surprised. And so he's making the argument in this post that we should potentially rename eventual consistency eventual convergence. It's a more specific term, and we don't have the overloaded meanings. So this is my attempt to look at that word asynchronous and say, can we come up with a better name? I can't. But I'm at least going to take you through my thinking, and maybe we'll get some better answers afterwards. Maybe you can help me come up with some better answers. Now, at this point, I wanted to start looking at different definitions of what asynchronous means. And if I was Kevlin Henney, I would then do lots of research and read books. But I'm fundamentally much lazier than Kevlin is, so instead, I asked Twitter. And what I found may shock you. Well, not maybe as much as it normally would, because it's before Musk took over, so it was a slightly nicer place. But I got lots of really interesting responses, a number of whom from people I knew. One of the first responses I got to this question, what is asynchronous, what does it mean to you, was from Darren Hobbs, who's an old colleague of mine based in the UK. And for Darren, he said the difference for him between synchronous and asynchronous interaction is the difference between sending an email versus having a phone call. And I sort of thought, and the first reaction to this is, well, that sort of implies that asynchronous is slower than synchronous communication. And I know that's not necessarily true. And I've worked on lots of very, very low latency systems that use asynchronous communication, so that didn't quite feel true. But there is something about that analogy, around that metaphor, that seemed useful. So there's something in there that might be helpful. And so while this Twitter thread is going on, I thought, okay, I should do some reading. And so I went and took a look at the reactive manifesto. So a couple of things to say about the reactive manifesto. Well, 3 things. Firstly, it's very, very popular. Who here has read the reactive manifesto? Quite a lot of you. Who here has signed the reactive manifesto? There's a lot of people that have signed it. I'm not sure the people that have signed it have read it, but anyway. Now, first thing. Second thing to say is there's some very smart people put a lot of hard work into putting the reactive manifesto together. And I know a number of those people, and I trust them and have learned a lot from them. I will also say I don't actually like it that much, because I feel it's a bit dogmatic and also vague, which is a really odd distinction. But nonetheless, there is a lot of useful, valuable stuff in here. I'm saying all of this before I start poking holes. And I just, with due respect to the people who wrote it, you can find me later. You know where I live, right? So in this, they actually attempt to define what asynchronous means. And this is not an easy job to do, as I'm going to show you in this whole talk. It is not something that's easy to do, but they've at least made an attempt. So well done to them. So they say that what asynchronous means for them is, in the context of this manifesto, which is great, they're setting a context for a meaning, we mean that the processing of a request occurs at an arbitrary point in time, sometime after it has been transmitted from client to server. So let's try that again. The processing of a request. So implicitly, they're sort of talking about request-based interactions, not event-based interactions, although actually the manifesto says you should use events. So this is already confusing to me. But anyway, the processing of a request occurs at an arbitrary time, sometimes after it has been communicated. As opposed to what? Like before? So I can process a request before I send it? Now, unless you found some kind of new kind of networking protocol that I don't know about that might be backed by a TARDIS, that's not possible. It also can't happen in the same instance either, because you can't communicate information instantaneously between 2 points in time, at least not until we find a way to make quantum entanglement work as a read-write networking protocol. So this term is kind of meaningless because always we're going to process it afterwards, because we live in a universe where effect follows cause, right? That's the causal nature of the world. But there is actually other useful stuff in here. So you go a bit deeper into the reactive manifesto, and they define asynchronicity in sort of in opposite terms to synchronicity. And they say, this is the opposite of synchronous processing, where the client only resumes its own execution once the service has processed the request. Now, this is actually something different, and this has a very specific term, and that term isn't asynchronous. So while I was doing my reading, the tweet responses come in, and I had a response here from Steve Smith, another very tall, very helpful person in the UK, knows lots about continuous delivery, works for Equal Experts. And he said, his initial response was, well, for me, right, it's TCP connections that are open for the duration of a communication. That's what synchronous communication means to him. And as you know, I like poking at people and going, is that what you meant? And I said, okay, so if I use a different networking protocol, would that not make it synchronous, or would that change? And he sort of clarified and said, well, actually, what I mean is, I assume you're not blocking for a response. And this is kind of what the reactive manifesto was talking about in that definition of synchronous and asynchronous, without actually explicitly in that context using those terms. That's really non-blocking. So let's talk about what non-blocking is. So let's take a simple example of interactions between a few microservices. So here I've got an enrollment microservice carrying out some business process, whatever. We don't actually care too much about the details at this point. Again, that's for programmers to work out. We've got two microservices that the enrollment microservice needs to communicate with. We have the loyalty microservice, and we have the subscription microservice. And what we want to be able to do is to go to the loyalty microservice and say, look, here's some points. Right, thanks for signing up, here's some points. And we also want to upgrade your subscription to a new level. Now, these two operations don't have to happen sequentially. They're not necessarily ordered, but they both need to complete. Simple enough. Now, if we took, a fairly straightforward, potentially naive approach to implementing this code inside the enrollment microservice, we might write it in a standard kind of, imperative style, somewhat like this. So the first thing I do is I execute a call to the loyalty service, and I say, award points, here's some points for you. And I will wait until I get the response. And once that response has returned, I will then go on to the next line of code, where I will actually then upgrade the subscription. So we initiate the call, we block, we wait until that call has completed, and then the next line of code executes. If you want to see this in action, go and write a little bash shell and have two write 2 lines of code that just run a little curl on www.google.com, right? You'll get the first response, then you'll get the second response. So it's only once the first request has fully completed can we then call the subscription microservice. This is blocking. Now, obviously, you can start to see some of the problems associated with blocking calls. The big issue really is the latency of this operation is now going to be the sum of those calls. So how long this operation takes is going to be constrained now by the first operation completing in its entirety, and then the second round trip completing in its entirety. So if, for example, the first call took 50 milliseconds and the second call took 150 milliseconds, the total duration for this operation is now going to be 200 milliseconds. And yet, actually, these two operations aren't actually linked. And of course, we do actually have to remember that you should never really look at latency in terms of being a raw number or an average, because tail latencies are a thing. So a latency should always be looked at in terms of a histogram. What you'll actually find is if you're actually summing up latencies like this, you'll actually end up with a wider overall range of latencies, which can actually make your system harder to manage. But an obvious improvement here would be to say, well, if these two things aren't linked, let's do them in parallel instead. So what we're going to do is, rather than do one operation and then wait for the next operation, we're basically going to do them at the same time. Now, back in the early days when I was first programming in Java, well, a bit later than that, right? So I'm old. I used Java from 0.91, right? So I've been around a long time. Before we had good concurrency primitives, you would try and do some complex threading code yourself. Nowadays, we don't need to bother because we have these lovely things called reactive extensions. So what I've done in this example here is that I've wrapped the invocation of these service calls in a future. A future is a read-only type, the value of which is going to be based on a potentially still pending operation. Different programming languages have different ways of doing this. Be looking at RX or Java, for example, the reactive extensions for .NET, different ways of making this happen. So when I create that future, what's actually happening is that in the parentheses, that operation is being kind of dynamically pushed into a background thread. So in a Java-based application, that would become a separate operating system thread, although we are getting green threads again soon, apparently. So, but effectively, what will happen is that first line of code will execute and will then come down to the second line of code, even if the first operation hasn't yet completed. We're not waiting for the call to actually be made. So behind the scenes, this future is in handling all the threaded code for us. So now effectively, those calls are going to be done in parallel, right? Which is really good, right? So it's definitely going to improve things from a latency point of view. So this is why people like non-blocking. Okay. Is it though? Is it though? Because what if you actually want the responses? Might happen, right? You might actually care about the results. You might need to do something with the results. Let's imagine a situation. At this point here, if you think about reading the code, first line of code executes, second line of code, at that point, we do not know if those calls have actually completed or not. They may not have completed. They may not even have started yet. They might be in flight. They may have finished an error. They may not have finished. So if you actually care about those results and those responses, and you need to do something with them, what do we need to do? Well, it turns out we need to wait for the responses. How do we wait for responses? With something like an await. And that says block the program until those operations have completed. So now are we non-blocking or are we blocking? I forget. Which one is it again? So even if you are doing non-blocking, the logic of your processing may require that you block, waiting for things to happen. If you have to do A and then use the results of A to then do B, for example, you're blocking. So is it non-blocking or blocking? I don't know. I don't know if I'm reactive or not. But another way of putting this is that even if you have non-blocking calls, you might end up blocking. And yes, there may be ways to redesign your application interactions to avoid this, and if you can, you should. I don't want to say you shouldn't do non-blocking, you absolutely should. In general, non-blocking calls are a good idea, and in general, you'll find that you'll benefit from them, especially now that the programming primitives around doing things like this are much better. You have the added benefit, of course, that non-blocking calls, by making use of threads, are much more likely to make use of multi-core systems as well. So let's come back to our Twitter thread. Here's Graham Lee, who used to work on Tyro, which is a payments company and bank in Australia. Has worked on sort of large-scale complex systems before. And so Graham started off by saying, okay, the definition I've been using is the sending service doesn't wait for completion of the receiving service before continuing and or completing its own work. So that first part of Graham's definition is definitely about blocking, non-blocking. So we're starting to see the common definitions being used here. But he then goes on to say, but now that I think about it, I also expect a temporal decoupling from the receiving service's availability. Temporal decoupling, of course, being the title of the first Doctor Who special that's coming up in the autumn. Temporal decoupling is actually a term in this context which describes a property whereby if I need to do something or ask another microservice for something, I can do that without that other microservice being currently available. Temporal decoupling does have other meanings in other contexts in computing. This was sort of backed up a bit by another tweet response I had. So Benjamin was saying, okay, well, synchronous communication is a direct connection. Asynchronous communication, Benjamin assumes some kind of intermediary. And he gives the example of a message broker. And intermediaries are commonly used to implement asynchronous communication. And they can actually help us achieve this property of temporal decoupling. When we talk about intermediaries for service-to-service-based communication, the most common form you'll hear of will be something like a message broker. They come in many shapes and sizes. We have things like RabbitMQ, you've got things like Kafka, you've got things like ActiveMQ, and they are actually as varied as databases, which is to say there's a common style of message brokers, but there's also some weird ones as well. Can be incredibly useful. If you've not used them, some of the core things they deliver are very, very sensible. And one of the things that they would typically be used for is to do what's called guaranteed delivery, which is kind of temporal decoupling by another name. So here I've got service A, and service A is going to send something. Now, I talk generically about the things we send over a message broker as being a message. Could contain a request, could contain a response, could contain an event. So service A here has a message that it wants to send to B. But what if B isn't currently available right now, or currently reachable? Maybe it's at a capacity limit, or maybe it's offline being redeployed. So what I do instead is I say, look, I want to get this to B, so instead you hand it to the broker. And it's now the broker's job to decide how that message then gets delivered to B. Now, if B's available right now, it might get there straight away. If B's not available right now, we might have to wait until B becomes available and says, I'm ready to receive new messages. And the brokers, the message brokers, will do all of that stuff for you. And so this is kind of what we mean by guaranteed delivery. The broker, once it acknowledges receipt of a message, is going to guarantee, I'm putting that in air quotes, that it will deliver. Now, whenever you use a message broker, they'll say they do guaranteed delivery. There'll be a big asterisk next to that term, guaranteed delivery, and then you need to look at what that broker means by guaranteed delivery because it can vary. Useful, intermediary, asynchronous for some. Okay. We had another response. Asynchronous is like dropping snail mail in a red post box and then going on with your life. So there's a bit of I'm putting it in an intermediary, the post box, and I'm getting on with my life. I'm sort of inherently non-blocking, right? Dropping it, non-blocking, walking away. And then one day, boom, Postman Pat arrives, stuffs something into your house mailbox, along with millions of coupons and charity mailers. For those of you who don't know who Postman Pat is, this is Postman Pat. This is the OG Postman Pat, not that new CG weirdo who rides the hovercraft. This is the proper stop motion. He's keeping it old school. So I'm not at my house right now, in case that wasn't evident. This is not a Will.i.am hologram, okay? We cannot afford that technology. And to be frank, we don't have the bandwidth. But I'm not at home, but I know things have been delivered at home. I have a letterbox in my front door, because unlike in America, we trust people to come to our front door without getting shot. So the letters arrive through my front door. When I get home, the letters will be waiting for me. Now, that sounds like my house is not occupied right now, and I cannot stress this enough. There are lots of people at my house, and there's lots of guard dogs, and I will not be burgled while I'm on stage. But nonetheless, when I get home, there will be letters waiting for me. I do not need to be in to receive my letters. So that metaphor of the post worker delivering letters, them being there when we're ready, fits really nicely with the use of intermediaries and brokers. It does again also imply a speed element. However, in practice, these things can be lightning fast. Typically, you pay for speed in these situations. And there are lots of variations on using this idea of an intermediary. You can implement it in different ways. You can use a database as an intermediary. You probably shouldn't, but you can. I mean, Oracle messaging is basically a wrapper on an Oracle database because, surprise, surprise, all solutions that Oracle provide are wrappers on an Oracle database. You can use a file system. Large swathes of the world's banking systems rely on moving files from one location to another. I generate a file, I put it in a shared file system, and at some point later on, another program picks that up. Again, implies something around latency with that, but is great for large volumes. You can also use email as an intermediary-based communication mechanism between services. Should you do that? No! There are better options, but it is a possibility. But the key thing here, when you've got an intermediary like that, the sender doesn't actually have to care about whether or not the recipient is actually currently available. That is what our temporal decoupling. We do need to have trust in the broker implementation we're using, of course, because we're now relying on that to be effective and efficient. And if you've got a choice between a reliable shared file system and an unreliable message broker in your particular environment, go with the file system. So I mentioned earlier that with things like, say, request-response-based in communication, that can be synchronous or asynchronous in nature. And if you think that asynchronous equals non-blocking, we've already looked at that. But what if asynchronous means intermediary-based? Well, if asynchronous means intermediary-based, how do we use an intermediary to implement, say, a request-response-based interaction? Well, this is a very simple example. Service A wants to send a request. And so what it does is it deposits that request in a queue, and this is the request queue for service B. So service B is listening for that queue. It is consuming messages that are coming on that queue. So B is now able to receive its request from that request queue. We've got a response. What now happens? Well, the response is generated at some point. That response is then sent back on a response queue. Great. This is intermediary-based, non-blocking communication, implementing a request-response flow. Going a bit deeper, though, into this, I mean, going from, say, the logical now into the implementation, and now we're going into the deployment architecture point of view. Simon will like this. It's all about different views on pictures. Go see Simon talks later about visualizing architectures. In reality, of course, it's quite common, if not likely, that we would have multiple instances of a microservice. So that creates an added complication for us with this kind of communication. Because I might have one instance from service A sending the request, but when that response comes back, that response could be routed to a completely different instance of service A. And some of you might look at this and think, well, that's a problem that's got to be fixed. I want to make sure that that response goes back to the original instance of service A that sent it. You would be wrong. Don't do this. This is better. The reason this is better is because A, if you add complexity into your routing to ensure that a response goes back to a specific instance of A, you are adding complexity to your system. And adding complexity to your system just creates more opportunities for your system to fail. And B, what happens when the instance that sent that request and expects that response back dies? On the other hand, if you build your system such that any instance of service A could receive that response, your system is actually simpler and also more robust, because then you could have destroyed and recreated all of your instances of service A, and any one of them can pick up that response where you left it off. So that's much better. Coming back to our non-intermediary based communication that we talked about earlier, we're opening that direct network connection but using those non-blocking calls. In this operation, there is the assumption, well, that the responses are going to come back to the same process that sent the requests in the first place. It's the same program. I'm sending something to you. I'm sending something to you. It's a direct connection. It's a direct pipe. So in this situation, we do have the added complication of now needing to reason about what happens if this process dies halfway through. We might have responses that go nowhere. Generally, with sort of these non-blocking, direct connection type interactions, the recovery mechanism is just you retry the whole operation from the beginning. So you just need to make sure that these operations are idempotent, and then you'll be fine. Saying just make everything idempotent is obviously A, the right answer, and obviously B, quite complicated. But it's arguable, though, that by using an intermediary for communication between services, that we're actually encouraging stateless processing, which I think is a good thing. So we've got competing definitions here, and it's starting to get a bit of a headache, and it's not just because of the epic quantities of coffee I've consumed this morning. We've got, for some people, asynchronous communication means we've got an intermediary. For others, it's talking about removing temporal coupling. Other people view it about being blocking versus non-blocking. And some people assume it's about speed. And for some people, they mix and match. Well, okay, for asynchronous for me is it's options 1 and 3. Ah, but I've got 2 and 4. So it becomes confusing. Which one of these is asynchronous? I did look at Tannenbaum, by the way, the Bible of distributed systems. So I looked at the most recent edition of Tannenbaum, which is freely available. The print edition is incredibly expensive, or you can just get it for free online by filling in a form. Do the second thing, right? The word asynchronous gets mentioned about 6 times in the whole book. Because Tannenbaum worked out, this is a rubbish term. He uses other terms. I don't agree with that either, but he can do his own talk. But the issue is here, right? We've got all these confusing definitions. Does it matter? Does it actually matter? At this point, you're thinking, really, does it matter? What's the point of this talk? You've wasted a lot of my time. I could be visiting sponsor booths. Words have different meanings. So a quick bit of audience interaction. Put your hand up if you can guess the word with the most dictionary meanings in the English language. Anyone know what it might be? Huh? It's not, it's set. You were close, 1 letter off, we had get. Anyone want to guess how many definitions in the full Oxford English Dictionary, which is kind of, for the English language, is the definitive set of words in the English language. How many definitions do people think set has? Huh? 400? We had 400. Yeah, not far off. The new word that's going to have the most definitions is the word run, which is going to be in the next edition, which is coming out in 2037. The current edition was done in 1980. When you see how much work goes in, you realize why it takes a long time to issue new sets. So set in the current edition of the Oxford English Dictionary has 430 meanings. At the moment, well actually as of a few years ago rather, back in 2011, they reckoned that run at that point had over 645 meanings. Now, clearly you might not be able to list those 645 meanings, but I suspect even for those of you who speak English as a second, third, fourth, or even fifth language, I barely speak one, right? For those of you who speak English as a second, third, fourth, or fifth language, you probably already know multiple definitions of multiple meanings for these words. Because we use these words in different contexts. We're used to it. So again, why is it an issue? The problem is that we work out what a lot of these words with multiple meanings mean based on the context in which a word is used. I was talking to Ian Cooper about this at the beginning of the year, and obviously it turned out that Ian Cooper, because some people have a hinterland, Ian Cooper's got like a whole alpine system behind him, right? He actually studies semiotics at university. Semiotics is the study of meaning. It's also the study of the sitcom Community, but that's a separate conversation. And in it, he said the reality is when you're thinking about this stuff, the more words you put around a word, the narrower the definition of that word becomes. So as we put more explanation about a word, our understanding of that meaning becomes much more defined. We narrow the potential set of meanings. So let's take a look at run. I put no words around run. It's the word run, nothing else. I want each of you now to think, what does run mean to you? What's the first meaning of the term run? Just think about that in your head. So now I'm going to put some words around it. The issue got worse the moment the program was run. Was that meaning the same one that you had in your heads? Maybe, maybe not. Let's try it again. So again, think of a different definition of the word run in your head. Think about it in your heads. Let's put some more words around it. The economy crashed due to a run on the banks. Very timely. Was that the same definition that you had in your heads? There's a couple of people are shaking like visibly and nodding because they lost money or something, I don't know, but a lot of you, no, again. So we're used to this kind of, right? We're used to having terms, having different words. So again, does it matter? The problem, though, is that we talk about the term asynchronous without the context. We say things like asynchronous is better than synchronous. The reactive manifesto tries to put some words around it that don't actually add enough meaning to be specific enough. You should use asynchronous communication. Well, you need other words around that to explain what the hell you're talking about, because we might be thinking two different things. Let's come back to the reactive manifesto, look at the words that they've used. At the very beginning of this, they actually say, the Oxford English Dictionary defines synchronous as not existing or occurring at the same time. This is indeed one of the definitions of the Oxford English Dictionary. It's the one you get when you Google, what does the Oxford English Dictionary define asynchronous as? It's the first definition that's freely available. Now, at this point, it's quite useful to have access to the full Oxford English Dictionary, which I do because my brother is a medieval historian. It's a long story. So he can get me the full Oxford English Dictionary definitions. In fact, if you live in the UK, anybody can. You can get it through your local library. You can use it online. It's quite cool. So there are actually lots of definitions. We look at the first definition that was used in the Reactive Manifesto, and is the one that most people would use online. We realize that that definition of asynchronous was only used in medical contexts. So we've taken a word with a meaning that was derived in medical contexts and applied it in the context of computing. So wouldn't it be better if the Oxford English Dictionary had actually made definitions of what asynchronous means in the computing context? And oh look, they did back in 1987. There's actually two different definitions. One which only applies really within a process, and the other which does talk about communication. So this is the definition of asynchronous in the Oxford English Dictionary in the context of inter-process communication. Designating data transmissions in which packets of data are sent at irregular intervals, which the start and end of each packet being marked by specific signals involving such transmission. I don't know what that means. I recognize the word packet, but again, this actually does make sense. All of these meanings are cited. They have footnotes. You can go and look at the source material for these definitions. That's why this thing takes so long. But this is talking at quite a low level of interaction. This is talking about the level of designing networking protocols to an extent. Are any of you thinking about sending an individual packet? Put your hands up if your day job involves thinking about sending a single packet. Not a single hand goes up. That's not the level we work at. We work at a high level of abstraction. So this meaning, being more specific to our context, is also still meaningless. The reason this is important is that fundamentally software is a type of socio-technical system. Socio-technical system, right? Socio meaning people, technical meaning technology. Technology in the Greek sense, meaning a body of complex knowledge. At this point, you're thinking, oh my God, he's one of those left-wing snowflake, wotarati, tofu-eating Guardian readers who's going to start ramming politics down our throats. Not yet, I'll do that in the break, right? This is not some new term being used by the people who thinks that, oh, I don't know, maybe people should be nice to each other. This is actually, the term socio-technical comes from a study of coal mining during World War II, right? This is a term we've been using for a while, bringing people and humans together and complex systems of knowledge. How do those two things come together to build effective systems? Software, the amount of software created by individuals is vanishingly rare. And before you say, oh, well, Linus created the kernel, he didn't. He did a lot of work, but most of what he was doing was actually bringing other people's work in to create the kernel. It's also why Git exists, which is also why arguably the Linux kernel is therefore evil, because it made us use Git. But that's a separate problem. People come together to create software. Bringing people together to create things requires good communication. It requires us being on the same page. So if you've got two people having a conversation, we're going to make this asynchronous, and you have two different visions of what that means. Are you going to come together and build a coherent system? Maybe not. And we've learned this lesson, well, maybe we haven't. Let's go Old Testament, Tower of Babel. It's only 3 verses in the Old Testament Bible, but it tells a story about a people who come together and speak of one language. It also actually mentions that the reason they're able to build this tower was because of advances in construction material, but no one ever mentions that. But it is in the original verses, right? So new tech, who dis? So they come together, they speak the same language, and they build a big tower. And then the Old Testament God, who wasn't the nicest person in the world as far as I can see, he's a very fire and brimstone kind of person, said they're building a big tower, I can't be having that. And he said, you now speak different languages. And the whole thing fell apart. It's almost like an inverse Daenerys Targaryen character arc. You know, like where there's a kind of a 180. It's like between the Old Testament and the New Testament, someone got new writers maybe, because it was much nicer in the second half. So, when we speak together of one purpose, we can build a big, giant, lovely, tall building. We start speaking different languages, using different terms, it becomes more difficult to do this. And the problem is, the term asynchronous in the context of inter-process communication means so many different things to so many different people. So what can we do about that? Start with talking about what your application needs. What does it need? Describe how your application should handle different situations. What do you want to happen when your server is unavailable? What should you do? How fast does your application need to be? What should you do if the client crashes? Use more explicit terms. Say things like clients should be non-blocking. Say things like we should run operations in parallel. Say things like we should use broker X as an intermediary. Don't try and make this about policing terms, because that's my job, right? Don't try and make this nasty. In The Princess Bride, Inigo Montoya says to Vinicus, you know, you keep using that word. I do not think you mean what you think it means. In this context, he is policing language. He says society knows what the term inconceivable actually means, and Vinicus, you are using it wrong. You can feel that actually, although he was doing it in the nicest possible way, he's policing him on his use of language. When it comes from Mandy Potemkin, I'm kind of, yeah, I let that slide. But be nicer about this if you're in your place of work. So maybe next time when you're having a conversation with colleagues, when somebody says, we should make this asynchronous, maybe just ask the question, what does that mean to you? Because what you find may shock you. Anyway, that's me. I'm done. Go visit sponsors' booths, and I hope you have a great rest of the conference.